3 algebra on this Monday. We are continuing talking about CO29. Introduction to ratios. You should have this chart already filled out. We talked about what a ratio describes, right? It's a part to a part. It's different from a fraction, even though it can be written as a fraction, which is kind of confusing. But a fraction compares a part to a whole. There's a ratio compares a part to a part. If you didn't get this filled out for whatever reason, go check the video already posted from last week Thursday, and you can get the data from there. Then we started putting things into ratios. We did the first two together. We'll just do them again here for those that weren't here perhaps. But you were baking a cake, and the recipe calls for 32 cups of flour and 42 cups of sugar. What is the ratio of flour to sugar? So again, what a ratio does is it compares the part of the cake that is flour to the part of the cake that is sugar. And the order here matters. Since it's written as flour to sugar, we want to put the cups of flour first. So 32 cups of flour. We use that little colon to show that it's a ratio. 42 cups of sugar, right? We also talked about how total, we can see there are 74 cups of something in this cake. Hopefully you threw in some eggs too, otherwise it's going to be a really weird cake. But you can determine the whole from a ratio, but what it does is it compares that part to the part. We then simplified. Who can remind us how we simplify a ratio, or how we simplify this particular ratio? I know it's a Monday, but we already did this. All I'm asking you to do is regurgitate information. Yes.
You divide it?
Divided by what?
2.
We divided by 2. They are both even. So similar to how you would simplify a fraction, right? Okay. 32 divided by 2 is 16. 42 divided by 2 is 21. That's the ratio in simplest form. And the reason why we care about this is because, if you only wanted to make a cake half the size of the original recipe, but you wanted to taste the same, you're going to want to cut both parts in half, right? Not just one of them, okay? Otherwise, it's going to taste more floury or more sugary or whatever. You want to do it to both. So that's where simplest form matters. A pet store is 18 dogs and 48 cats. What is the ratio of dogs to cats? We have 18 dogs, 48 cats. What do we divide by to put this in simplest form? Tristan!
6.
We divided by 6. And that's going to give us 3 and... Why did I write 3? Oh, I was thinking 3. Divided by 6, that's going to give us 3 and 8, which basically means that for every 3 dogs in the pet store, you have 8 cats. So if you wanted to keep this ratio the same, if you got 3 more dogs, you'd have to get 8 more cats. Okay? If you sold 3 dogs, you have to sell 8 cats to keep that ratio the same. All right? That's what we covered on Thursday. Okay, so now going ahead, similar stuff. In a football stadium of 60,000 fans, 40,000 are Vikings and 20,000 are Packers. Oh, the wound is still fresh. What is the ratio of Vikings fans to Packers fans? The part of the whole, the part of the stadium that are Vikings fans compared to the part of the stadium that are Packer fans. What do you come up with? Okay. How many Vikings fans are in the stadium? Yes.
40,000.
40,000. Okay. 40,000. How many Packer fans are in the stadium? 20,000, right? So the part of the fan base that are Vikings fans, the part of the fan base that are Packers fans, that's where you get this 40,000 to 20,000. Notice if you add 40,000 and 20,000 together, what do you get? 60,000, which is the whole, right?
Wow.
So the part plus the part will equal the whole. Okay. Putting this in the simplest form, what can we divide 40,000 and 20,000 by? Put this in the simplest form. Is that a hand? No. Okay. Nolan? We can divide by 10,000, but there is a larger number that goes into each of them. 20,000 would be the most efficient way, okay? And if you divide 40,000 by 20,000, you get 2. If you divide 20,000 by itself, you get 1. Basically, it's a 2-to-1 ratio. There are twice as many Vikings fans as there are Packer fans in the stadium. Okay? All right. The next kind of set of questions here has us use ratios in a little bit different ways. And so in this case, I tell you what the ratio is, and then I give you the whole. And your job is to figure out, using that ratio, what the actual parts of the class are. It says the boy to girl ratio in a class is 2 to 3. Okay? Which means that for every 2 boys in the class, there are 3 girls. There are 30 students in the class, though. Okay? Which means that this ratio has been simplified. Right? Whatever the actual number of boys and the actual number of girls in the class are, it has to add to be 30. This 2 to 3 ratio has been simplified. So, any thoughts on how we would figure out the number of boys, the actual number of boys and girls in the class, if we know the ratio in simplest form, and we know how many kids there are total? Gregory, you look like you're thinking. Sorry, I interrupted you. Go ahead and think. Anthony?
Times 6.
Why times 6?
Because like if you times 6 to both numbers, and then if you add both of them, I get 30.
Yeah. So we can use scale factor here, right? Total 2 and 3 represent 5 kids.
Oh, shoot.
Right? 2 boys, 3 girls. In total, the simplified ratio represents 5 kids. I should say not 5 total. I should say 5 kids. Okay? And Anthony said we're going to multiply by 6, because if we multiply 5 by 6, what do we get? 30, right? Which is the total number of kids in the class. So what that means is that this ratio has been simplified by a scale factor of 6. Okay? If we multiply 2 by 6 and 3 by 6, we get 12 and 18. And as Anthony said, what does 12 plus 18 equal? 30. Okay? So when you're given the ratio and you're given the whole, you're given the total, what you're looking for is, what's that scale factor? Right? 2 to 3 represents 5 students. I need to get to 30. What do I have to multiply by? Okay? Very similar to solving proportions, right? Or solving percentage questions where we're looking for that scale factor before. Okay? Are there questions on this here?
No.
Okay. I think the rest of your assignment pretty much has to do with that kind of concept there. Let's look at the basketball score here. It says at halftime of your basketball game, the ratio of your score to your opponent's score is 7-4, and the sum of your scores is 33. What is the score of the game? Okay. So it gives you this ratio of your score to your opponent's score, which means that for every 7 points you have scored, they have scored 4. That's a good thing, right? Means you're ahead. But the sum of the scores is 33. The sum of these scores, 7-4, is only 11. So what's our scale factor here? Again, this ratio has been simplified. Total, what we know is we have 11 points here. We have to get up to 33. What's our scale factor? Someone knew. Someone heard yes. 3, right? If you multiply 11 by 3, you're going to get 33 points, which we're told is the whole. That's how many points have been scored total. And so our scale factor being 3, we're multiplying both 7 and 4 by 3. That gives us 21 to 12, which lo and behold adds to be 33 points. So the actual score of the game is 21 to 12. The ratio in simplest form is 7-4. For every 7 points you've scored, they've scored 4. Okay? The ratio of bottles of pop to cans of pop in a cooler is 4 to 3. there are 20 bottles. How many cans are there? What do we know? We have the ratio. And actually, I'm going to put our labels up on top here too. Bottles of pop comes first. Okay, so bottles to cans is 4-3. And then we're told there are 20 bottles. We're not given the whole here, right? We're just given one of the parts. We know there are 20 bottles, and we need to figure out how many cans there are. So this one is a little bit different from the ones up above. But again, we're looking for that scale factor. Someone haven't heard from me yet today. What's the scale factor to get from 4 to 20? Okay, in this case, we're not looking for the whole. We're given another part. Adrian?
15. You got times 3 by 5.
Yes. Okay, so the scale factor here is 5. Okay, if you've increased the number of bottles by a scale factor of 5, you want to increase the number of cans by a scale factor of 5 as well. And as Adrian said, 3 times 5, there are 15 cans. Right? So part of working with ratios successfully is knowing the information you're being given. Okay? You're being given a ratio. Are you then being given the whole? And you look for that scale factor from or to the whole, or are you given another part and you look for that scale factor from part to part, right? Questions on these two? Okay. Let's look at the next one. A sports store sells footballs, basketballs, and volleyballs and has them on the shelf in a ratio of 3 to 2. There's a total of 80 balls on the shelf. How many of each type is there? So pay attention to the information you're being given, right? You're being given the ratio, and there are 3 parts to it because there are 3 different types of items that we're talking about here. We're comparing, okay? Then you are given 80, which is 80 a part, or is it a whole? Total of 80 balls on the shelf. Does that 80 represent a part, like the bottles did? Or does it represent a whole, like the students in the class or the points in the game did? Anthony. Part or whole?
Part.
If you weren't paying attention, you have a 50-50 shot.
I was like daydreaming.
Yes.
On the.
Yes.
So you're saying.
So 80. Is 80 a part or does it represent a whole?
Oh, whole.
The whole. Okay. So you'll be doing like we did in the point question or the student question, right? You're looking for that scale factor to get to 80. A recipe for your soon-to-be world famous mushroom muffins calls for 2 cups mushrooms and half a cup of corn. In simplest form, what is the ratio of mushrooms to corn, and how many cups of corn are needed to increase the recipe by a factor of 6? You want to make these mushroom muffins, not just for one person, but for 6. Schultz, Boyle, Steele, Surik, Olson. We'll give some to Dawson too, right? So you have to increase this recipe by a scale factor of 6. How many cups of mushrooms and how many cups of corn are you going to need to do that? It does say in simplest form, okay? For a ratio to be in simplest form, you can't have any fractions in it, right? So the original ratio is like 2 cups mushrooms to a half cup of corn. Simplest form would mean we are rewriting that 1/2 as a 1 whole, right? And so how would that change the cups of mushrooms? Okay, and then if you were to do that recipe 6 times, how many cups of each item would you need? Right? Sound disgusting though. I'm just saying. You have 12 green circles. How many blue squares would you need for the ratio of circles to squares to be 2 to 1? So this is one of those part questions where you know how many circles you have. We'll do circles to squares. We know we have 12 green circles. We want the ratio to be 2 to 1. How many squares are we going to need? All right, that's how I'm going to set that one up there. okay? Because that 12 represents a part, not the whole. You have 18 green circles. How many blue squares would you need for the ratio of circles to squares? Would be 6 to 5. Very similar. And finally, you have 30 green circles. How many blue squares would you need for the ratio of circles to squares? Would be 6 to 11. So these three are all very similar. You're given a part. You're given that final ratio. You need to find that scale factor for how many blue squares you would need for that ratio to exist. Okay? Do you think we could play the number game tomorrow?
Yeah.
Zoe, you're a non-believer?
Huh?
You're a non-believer?
Oh no.
Oh, you shook your head no. Oh, yes, you do believe? Okay, Tristan, do you believe?
Yeah.
Maya, do you believe? Anthony, do you believe? I believe.
Yeah.
Okay, you've got 9 minutes to work on the rest of this objective. It is homework for tomorrow. Okay, work. Hey, just so no one can accuse me of not saying this tomorrow, work does need to be shown. Okay, Nolan, does work need to be shown? Yeah. Scarlett, does work need to be shown? Anthony, does work need to be shown?
I mean, for the last three.
For all of them that you're doing on your own,
I'll try.
you'll try. Thank you, Anthony, for your best effort. All right, folks, finish the objective. That's on your math.
Don't forget to like and subscribe.
Thank you very much. Thank you very much.
Thank you for you, Kevin.
Appreciate that. Yes, Josie. Oh, it's not a hand up. Okay. Did I not stop recording?